more talk on the terminology of tree, and here there are two terms. The one term is height and the other is depth. What is height? Height is actually you measure the height from the lowest from the low leaf node to the root node, and so you starting count from the leaf node, and the height of the leaf node is 0, then 1, then 2 onward. But the height of the root node is actually the maximum height possible in that tree, and in this case the maximum possible height will be from this leaf node. If we count height from this leaf node, it will be 0, 1, 2, 3. So at every given point we write the maximum possible height in that branch. And in the same way you count depth from the root node onward to the towards the leaf nodes. So depth of the root node is 0, this is 1, this is 2, and for any given tree the depth of the tree is the maximum depth of that tree, and the maximum depth of this tree is depth 3 from in this branch. And next we see the full binary tree. Full binary tree is actually a tree where every node has 2 children. So this is a full binary tree, and this is a very sparse or unbalanced tree because here every node doesn't have 2 children. This node is also called a balanced tree. Next is the terminology of levels. Levels means this is one level, this is level 2, this is level 3, this is level 4. The difference is that in this case you start counting depth from 0 index, but you start counting level from 1. And if you want to count the nodes in a tree, you can simply use this formula 2 to the power level minus 1. Like in this tree you have 5 levels, 4 levels, 1, 2, 3, 4. So you raise power 2 to the power 4. 2 to the power 4 is equal to 16, minus 1 is 15. So if you count these nodes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. And finally we see another term that's called the binary tree versus binary size tree. Binary tree, as you have already seen, this is a binary tree where every node has 2 nodes. But here we do not have applied any rule of insertion for the binary tree. We can insert any node on any side of the parent node, so it is not easy to search. For example, look here, this is a node, this is a tree, and in this tree let's say we have to search the node 5. So if we have to search the node 5, what we will do, we will search all the levels, level 1, level 2, level 3, and finally we will get this node at this point. This is the 5 node. So in simple binary tree you have to traverse all the nodes to find the required node. So the complexity of search in simple binary tree will be O of n, because we have to traverse all the n nodes, and it's equal to the complexity of a linked list, or you can say simply an array. So in simple binary tree you do not get any edge in finding the desired node. But in binary search tree you insert the nodes in such a way that you follow a specific rule, and that specific rule is that the smaller node will always be inserted on the left side and the bigger node will always be inserted on the right side. So this is a tree, and here we will always insert the smaller node on the left side and the bigger node on the right side. So first of all we inserted 7, then say we try to insert 5, and 5 is less than 7, so it will be inserted on the left side. Then we inserted 9, it is bigger than 7, so it will be inserted on the right side. Similarly, if now comes 10, it is bigger than 7, bigger than 9, so it will be inserted on at this point. So now if you want to search the node 5 in this balanced and binary search tree, it will be very easy, because like if you want to search 5 node, you will come here at this node, and here you will compare the node 5 with this node 7, and you know 5 is less than 7, so you will reject this branch altogether. So this subtree will be rejected. You will never come here, you will go only to the left side, and compare with the next node, and hurrah, you got it here. So in one step you find the desired node. So this is the difference between a binary tree and binary search tree. So stay tuned for the next lectures.